Small angle approximations. Hit pause, make some notes, and let's have a look at some small angles. So on this grid here we've got two curves. We've got our sine curve here, and here's our sinusoidal sine curve, and we've got a straight line y equals theta. Now for very small angles, we're in radians here, going up to just over 6 for 360 degrees. For small angles, very close to 0, the straight line y equals theta approximates to sine theta, just for very small angles. So your y equals sine theta tends towards y equals theta. So we can say that when theta is small, or for very small angles, I'll just change this into a blue pen, sort of to highlight it a bit better. Tell you what, I'll actually use a highlighter. So when theta is small and measured in radians, we can say that sine theta approximates to theta, and that's up here. So hit pause, sketch the curve, and it's just for very small angles close to 0. We can say that sine theta approximates to theta. Okay, good. So hit pause, make some notes. When you're ready, hit play again. This time on our grid we've got two curves. We've got our cosine curve. Our cosine curve is here, as normal. And we've also got this other curve, y equals 1 minus theta squared over 2. And that's this quadratic curve here. Okay. Now, that quadratic curve, again, very close to 0. So for small angles in radians, we can say that this curve approximates to cosine theta. So there we are. Y equals cos theta tends to our quadratic curve, y equals 1 minus theta squared over 2. So making some notes then, again, I'm going to highlight what you need to write down. When theta is small and measured in radians, cos theta approximates to 1 minus theta squared over 2. So hit pause, make some notes. We've now got two approximations. Sine theta approximates to theta, and cos theta approximates to 1 minus theta squared over 2, as long as theta is very small and measured in radians. And as you can imagine, we're going to look at the tan curve. So we've got our tan curves here in red. That's y equals tan theta. And we've got a straight line graph, y equals theta. Again, for very small angles, very close to 0 there, very small angles, what we can say is that when theta is small, measured in radians, tan theta approximates to the straight line, theta. So that's our third approximation. So you can hit pause, make some notes, and when you're ready, we're going to have a look at an example. So hit pause, make some notes, and we'll look at an example next. So in this example, it says when theta is small, let's just make sure we've got a pen here. So when theta is small, find the approximate value of sine 2 theta plus tan theta all over 2 theta. So let's rewrite that here. Sine 2 theta plus tan theta divided by 2 theta. Now, we can use our small angle approximations because they tell us to. They tell us when theta is small. So sine 2 theta is going to be approximately 2 theta plus tan theta, it's going to be approximately theta, divided by 2 theta. So if we simplify, on top we've got 3 theta divided by 2 theta. I can cancel my thetas, just change that to a blue pen, so I can cancel the thetas, top and bottom. So that equation is approximately equal to 302. And that's that. As easy as that. Hit pause, make some notes. When you're ready, hit play again. I'm just going to highlight this section here. They give us information. Theta is small. Good, so hit pause. When you're ready, hit play again. We'll look at another example. Okay, second example. When theta is small, let's highlight that. So let's make sure I've got my highlighter on. There we go. When theta is small, so theta is small, find the approximate value of cos 4 theta minus 1 divided by theta times sine 2 theta. Okay, so let's have a go at that. We've got cos 4 theta minus 1 divided by theta sine 2 theta. Now cos 4 theta approximates to 1 minus 4 theta squared over 2, because remember it's not theta and there's 4 theta, so that's going to be 1 minus 4 theta. Remember both terms are squared, divided by 2 minus 1, all divided by theta times sine 2 theta is approximately going to be 2 theta. Okay, good. 1 minus 1, they cancel each other out. So you got 1 minus 1. So they've both gone. Oops. Let's change that back to red. So that's going to be equal to minus, if I square that, I get 16 theta squared divided by 2, and that's all over 2 theta squared, which is equal to 16 divided by 2 is 8, so it would be minus 8 theta squared divided by 2 theta squared. Now the theta squareds cancel each other, so we've got theta squared cancelling each other, so we basically got minus 8 divided by 2, which is minus 4. So there we are, our expression there approximates to minus 4. So hit pause and write the example down. When you're ready, hit play again. We'll look at one more final example. Okay, in this example it says show that when theta is small, so they give us that clue which we can highlight then. Sine of 5 theta plus tan 2 theta minus cos theta is approximately equal to 2 theta squared plus 7 theta minus 1. So let's have a go at proving that the left hand side is approximately equal to the right hand side. In order to do that, I'm just going to write we'll take the left hand side, LHS, left hand side, so that's sine of 5 theta plus tan 2 theta minus cos 2 theta. That's equal to sine of 5 theta approximates to 5 theta. Tan 2 theta approximates to 2 theta. And then minus cos 2 theta is approximately equal to 1 minus 2 theta squared over 2. So it's minus. Because it's minus, I've got two terms, I'm going to put brackets around them. So it'll be 1 minus 2 theta all squared divided by 2. So let's expand and simplify. It's going to give me 5 plus 2 is 7 theta minus, and in the brackets there I've got 1 minus 4 theta squared divided by 2. That's 7 theta minus 1 plus, minus and minus gives me plus, and 4 divided by 2 is 2 theta squared. So that's pretty much the expression that we've got to have it approximately equal to. I should technically use the approximately equal to symbol here. Let me just change those. Approximately equal to, not equal to, because we're using our approximation. Okay, I'm just going to rearrange it to have 2 theta squared at the front, so that's going to be approximately equal to 2 theta squared plus 7 theta minus 1. Okay. Now, I've still got thetas in here, but the thing is, when theta is small, it's negligible. G-I-B-L-E. So as it's negligible, we can say that sine 5 theta plus tan 2 theta minus cos 2 theta is approximately equal to, and because it's negligible I can ignore 2 theta squared, ignore the 7 theta, anything with theta in, it's approximately equal to minus 1. Good. Hit pause, make some notes. When you're ready, hit play again, and you can do some work for me. And those are approximations we've used today. You've already got notes for those, so I don't think you need to make additional notes. Okay, so we're working on exercise 5F, page 134. You've got 5 questions, and I know you'll feel challenged. A challenge question to finish it off. Okay, good. Good luck.